Hey everybody, and welcome back to AI.Code.Cast. We're going to be doing a deep dive today into a problem that a listener wrote in about.
Oh, cool.
Yeah, it sounds super simple on the surface, but it's got some hidden depth to it.
I love those.
Yeah. And this is something that as coders, we encounter all the time.
I bet.
And it's comparing version numbers.
Ah, okay.
So, you've got these two version strings.
Right.
You're like, okay, which one is greater?
Yeah.
Or are they equal?
Right.
Sounds simple enough.
It does.
But, version strings aren't exactly like your typical decimal numbers.
Oh, of course, yeah.
They can have, different numbers of components.
Yeah.
Leading zeros, all sorts of quirks that can trip you up if you're not super careful.
For sure.
So, you start thinking about, 1.2 versus 1.2.3 versus 1 point shizit. Like,
Oh, yeah.
it can be a little bit, it can be a little tricky.
Yeah, can be tricky.
So how do we approach this problem without ending up in a big spaghetti code mess?
Right. I mean, what's the best way to do that?
Well, I think, probably the most intuitive approach is what I like to call the split and compare method.
Okay.
Um, it's kind of like, remember back in elementary school when we used to do place value?
Oh, yeah.
You break down each version string, right, into its individual numerical parts separated by those dots, those periods.
Okay.
And then you compare those parts one by one. It's kind of like you go down a checklist,
Makes sense.
So, it's pretty straightforward for simple cases. But what happens when you have, version strings with different lengths, like we were just talking about, 1.2 and 1.2.3?
Yeah, that's a great point. Like, how do you even begin to compare those?
Right. Well, that's where a little bit of padding comes in handy.
Padding.
Yeah. So you basically, you add trailing zeros to the shorter version string until it has the same number of components as the longer one.
I see.
So 1.2 becomes 1.2.0. So then you can directly compare that to 1.2.3.
Oh, okay.
And it's all about making sure we're comparing apples to apples, numerically speaking.
Gotcha. Yeah, no, that's simple and easy to grasp. But I do have a feeling there's probably a more efficient way to do this, especially with those really long version strings.
Oh, you read my mind. That's where it gets really interesting.
Okay.
So let me give you a hint. What if, instead of breaking down the entire string from the start,
Yeah.
what if we could compare segments on the fly as we encounter them?
Oh.
What if?
I think I might see where you're going with this. Sounds like we need some pointers.
You got it.
Yeah.
That brings us to the two pointers technique,
Okay.
which is a much sleeker and more efficient way, especially when you're dealing with those, massive version strings.
Got it.
Okay, so walk me through this two pointers magic. How do we use these things to compare version? Imagine you have these two pointers, one for each version string. They're kind of like they start at the beginning,
Right.
and they move along comparing these numerical chunks on the fly. They don't split the whole thing beforehand.
Right.
So it's kind of like, two sprinters racing side by side,
Okay.
comparing their positions at each checkpoint rather than waiting till the very end.
Yeah, that makes sense. That's a lot more efficient. But I imagine it's probably a little trickier to actually implement than the split and compare method.
It might seem a little more complex at first, but trust me, it's super elegant.
Okay.
Once you understand how it flows,
Mm-hmm.
it's kind of like it's a dance between these pointers,
Okay.
gracefully moving through those strings.
I like it.
It's all about clever pointer manipulation
Right.
and knowing when to extract and compare those numerical chunks.
Okay. Yeah, I'm starting to see the appeal of this two-pointer tango.
Yeah.
But before we get too deep into the nitty-gritty of this two-pointers technique,
Yeah.
maybe we should address some common questions or potential pitfalls that might pop up.
Ooh, yeah, that's a good idea because, I always say the devil's in the details,
Always is.
especially when it comes to version comparisons.
For sure.
So, for example, like, what are some things we need to watch out for when we're handling version strings with those leading zeros?
Oh, that's a great question.
Like 1.01 versus 1.1.
Yeah, that's a very common pitfall, those leading zeros. They can be a little bit sneaky because version numbers, they're not always treated as standard numerical values.
Right.
Sometimes, 1.01 and 1.1 might be considered equal,
Right.
while in other systems, 1.01 might be considered less than 1.1.
So it really depends.
Yeah, context matters.
Yeah.
The specific rules of the system that you're working in.
It all boils down to how those leading zeros are handled within that that specific context.
It really does.
That we got to watch out for.
It is.
Okay, leading zeros, check.
All right.
What about empty segments in a version string,
Oh, that's another good one.
like 1.2?
Yeah.
Do we treat that as a zero or ignore it entirely?
It's a potential landmine if you're not careful.
Yeah.
Again, it depends. Sometimes an empty segment might be treated as a zero, while in other cases it might be completely ignored.
Yeah.
The key is to be consistent.
Yeah.
Define those rules clearly in your code. Whatever you decide to do, just make sure you're doing it everywhere.
Yeah, and be consistent.
Yep.
Okay, so what about trailing periods at the end of a version string?
Oh, another good one.
Like, should 1.0 be considered equal to 1.0?
Yeah, trailing periods can be a little tricky. And some versioning schemes, they're completely insignificant. You can just ignore them.
Right.
But in others, they might actually change the meaning of the version string.
Wow.
It's like, what are the rules of the game we're playing here?
Exactly, yeah.
What are the rules?
We got to know the rules.
Yeah.
So it sounds like the key takeaway here is we need to be very vigilant.
Be vigilant.
And pay attention to those edge cases, like leading zeros, empty segments, trailing periods.
Yes.
They might seem like small things, but they can really mess things up.
They really can, yeah.
So we've explored the problem a little bit. We've seen some things we need to look out for. Now, let's get back to this two-pointers method.
All right, let's do it. I'm ready to break it down.
All right, you ready to break it down?
Yes.
Okay, let's get those pointers dancing.
Let's do it. Welcome back to AI.Code.Cast, where we're diving into version comparison algorithms.
That's right. And in case you just joined us, we talked about what the problem is. We talked about some things you need to watch out for. And now we're ready to get into the two-pointers technique.
Yeah, this is a nice, elegant solution, especially for those longer version strings.
Okay, so I'm excited to see these pointers in action.
Yeah, so instead of splitting the entire string up front and creating these big arrays,
Yeah.
we're going to use pointers to kind of move through the string and just compare the segments as we get to them.
So instead of like mapping out the whole route beforehand, it's like we're exploring with these two little scouts.
Yeah, exactly.
Who compare their positions at each checkpoint.
Yeah, I like that analogy. So we've got 2 pointers, one for each version string.
Okay.
And we'll start those pointers at the beginning of each string.
Okay, got it. So the pointers are set. We're ready to go.
So what do we do next? Do we just start marching them along character by character?
Yeah.
Not quite. We want to extract those numerical segments, right, as the pointers are moving along.
That's the challenge. We can't just grab individual characters because those segments, like you were saying, could have multiple digits, right?
Exactly.
Yeah.
So how do we extract those segments without actually splitting the whole string first? I'll give you a hint. Think about those periods as separators.
Oh, like boundaries.
Yeah, boundaries between those numerical segments.
So each pointer would move along accumulating digits until it hits a period.
Exactly.
And then it would have that segment.
Exactly. So for each pointer, we would basically have a loop that's iterating over the characters, accumulating the digits into some temporary variable.
Okay, so let's say it sees 123, the first pointer. It would loop through, 1, 2, 3, and get 123
Yep.
until it hit the period.
And then it would have its numerical segment.
Got it. Then we compare the two segments, and if they're different, we're done.
Right, exactly. If they're different, we immediately know which one's greater.
Right.
And if they're the same,
Then we keep going.
then we move on to the next segment.
It's like they're doing this little dance.
Yeah, it's a very efficient dance.
Right?
We're not splitting anything. We're not creating any extra arrays. We're just doing it as we go.
Okay, I really like it. I'm curious, what happens when our pointers, reach the end of one string, but not the other?
Oh, that's a great question. That's a very crucial point. We've got to handle that case right, where the strings have different numbers of components. Remember that padding we talked about earlier?
Right, where we add those zeros to the shorter string.
Well, we don't actually need to pad the string explicitly. We can just do it implicitly as we're doing the 2 pointers method.
Okay, wait, how do we do that without actually adding zeros?
It's pretty simple. So when one pointer reaches the end and the other one still has some stuff to go, we basically just treat those remaining segments as if they were zeros.
Oh, okay, so like 1.2 versus 1.2.3.
Right.
Once we've looked at 1.2, it's like 1.2.0.
Exactly. And so we're always comparing on the same level.
I love it. I'm starting to see why this is, so much better for those longer strings. But I think before we move on completely to the next step, we should at least mention the brute force approach.
Yeah, of course. I mean, the brute force approach works too. I mean, it's not as elegant, it's not as efficient, but it is much easier to understand and implement.
It's definitely simpler. I think, it's all about choosing the right tool for the job.
Right,
I
exactly.
mean, sometimes, you don't need the super high efficiency. If you're just dealing with short strings, it might not matter as much.
And that's the beauty of coding. There's always a balance, right? There's always a balance between efficiency and simplicity.
So I think now we're ready to move on to um, actually looking at some pseudocode for these approaches. We've talked about the concepts. We've gone over the ideas.
Yeah,
Now let's try to visualize them in a more concrete way.
sounds good.
Welcome back to the show. We've been exploring how to compare version numbers, and we've talked about 2 different ways to do it.
We've looked at the split and compare method and the 2 pointers technique.
Yeah. And of course, all those little edge cases like leading zeros and empty segments that can really trip us up.
Definitely got to be careful with those.
So before we finish up, I think it'd be really helpful to look at some pseudocode for both of these approaches.
Yeah, that's a great idea. Pseudocode can help make those ideas a little more concrete.
Right, exactly. It helps us visualize the steps in a way that makes sense no matter what programming language you're using.
Yeah.
So let's start with the split and compare method because I think it's a little more intuitive.
Okay, sounds good. So let's say we have our 2 version strings. We'll call them version 1 and version 2.
Right.
The first thing we do, as the name suggests, is split those strings into their individual numerical parts, using the periods as separators. So in pseudocode, we could use a split function.
Yeah.
Something like this. Version 1 parts equal split, version 1 using the period as a delimiter.
Right.
And same thing for version 2. Version 2 parts equal split, version 2 with the period delimiter.
Okay, so now we have these 2 arrays, right? Version 1 parts and version 2 parts.
Exactly.
And each element in the array is one of those numerical segments.
Right. And now remember we talked about those version strings that can have different lengths. That's where padding is useful.
Right. We want to make sure we're comparing the same place values, even if one version string has fewer parts.
Exactly. So we can figure out the maximum length of those 2 arrays and then add zeros to the shorter one until it reaches that length.
Okay.
Just like we used to do back in elementary school.
Right. Okay.
And once we've got those arrays all padded and ready to go, we can move on to the comparison.
Perfect. So now we have these 2 arrays all nice and neat. How do we actually compare them?
Well, we can use a loop to go through those arrays at the same time, comparing the corresponding elements.
Okay.
Like, 2 judges looking at each segment side by side.
Right.
And if one of those judges sees a segment that's bigger, we know that version's greater, and we're done.
We can stop right there.
Exactly. No need to keep comparing if we already have a winner. And if we make it all the way through without finding any differences, then we know the versions are equal.
Awesome.
Yeah.
I like how clear and straightforward this split and compare method is.
Me too.
But I'm really intrigued by the 2 pointers technique.
Yeah, that one's super efficient. Remember, we're not splitting or padding beforehand with this method. We're going to extract and compare the segments as we need them.
Right, on the fly. Okay, so where do these pointers start?
We'll have 2 pointers, key 1 and P2,
Okay.
both starting at the very beginning of their respective strings at position 0.
Got it. So they're like ready to race through those strings.
Exactly. And to keep them moving and comparing, as long as there are more segments, we can use a loop.
Okay, a loop makes sense. It keeps everything going until we hit the end of one of the strings.
Right. So the loop will run as long as either P1 or P2 is still within the bounds of its string.
So whoever reaches the end first triggers the end of the loop.
Exactly. Now, inside that loop, we have to do a couple things. First, we got to grab the numerical segments that our pointers are pointing at.
Okay, but how do we do that without splitting the whole string beforehand?
We can use another loop, a nested loop, actually,
Okay.
to help us extract those segments.
A loop within a loop.
Yep. It's like each pointer has its own little helper that examines just its part of the string.
Like it.
So this inner loop will start at the pointer's current position and just keep going character by character until it hits a period or the end of the string.
And as it goes, it's building up that numerical segment, right?
You got it. So when this inner loop's done, we've got our complete segments, and we can compare them. Just like before, if they're different, we know which version's bigger. If they're the same, the pointers move on.
Okay, I think I'm following along. And what about when one string is shorter than the other?
We handle that implicitly, just like before, remember. If one pointer hits the end of its string, we treat those remaining segments in the longer string as zeros.
Right, so we don't have to do any extra padding.
Exactly. It's all built in.
I love how elegant this 2 pointers method is.
It's pretty cool. It's all about efficiency.
Well, we've covered a lot of ground today. We've explored the ins and outs of comparing version numbers, looked at two very different approaches, and even got into the nitty-gritty of pseudocode.
We did.
Hopefully now our listeners have a really good understanding of this important concept.
Yeah, and remember, understanding version comparison is crucial in so many different areas of software development.
It really is.
Whether you're managing dependencies, ensuring smooth updates, you name it.
Absolutely. Well, with that, I think we've reached the end of our deep dive. Thanks for joining us, everyone.
Happy coding.